to discuss the law of sines. Our objective is to be able to determine the area of a triangle given the side angle side information. We will also be using the law of sines to find side lengths and angle measures of any given triangle. All right, let's get started. All right, so right now we're going to observe the area of a triangle if and when you're only given the information about side lengths. For example, the one you're looking at right now, there are only two side lengths and a given angle between them. So we use this formula, okay, for the given using the sine function. And you have three possible options, and it doesn't really matter what order you use as long as you follow this. Okay, this is what I mean. If you're looking for the area, you're either using one of the angles given, right? So you need to substitute that theta, that angle measure, in degree based on the following. So really, you're just plugging in the information you have. And no, you don't need to use all three of these. You can just use one of them. And you do need a calculator, and I'll be showing the steps as well. Okay, so let's get you started on this one. All right, so given the two side lengths of this triangle, we're going to find the area, and we're going to round it to the nearest tenth. So 1 decimal place, all right? So right now I have the measure for angle A, okay? So following the written down formula right here, we're going to use the first one. All right, so let's use that one. I'm gonna copy it down here. We're going to plug in the information that we have to find the area of this given triangle. All right, so I'm gonna go 1/2 where the B value is 2.13. The C value is 2.96. And then we need to multiply that by the sine function of a 73-degree measure. All right, so let's use this information and enter it into our calculator. Now, some of you are using your own graphing calculators. That's absolutely fine, but make sure that the mode is correctly set up. So I'll show you the setup right now. Okay, this is what I need. You want your mode. Mode is right here. Make sure it is selected to be in the degree unit. Okay, so once you've got that set up, we can enter our expression in here. All right, so we're going to enter the information we just used. You have your 1/2. In this case, we can use 0.5. All right, like so. And then we're going to multiply it by 2.13, and then multiply it by 2.96, carefully making sure our values are correct. And then we're going to multiply it by the last part, sine of 73 degrees, the given angle measure. All right, and then we're going to hit enter. Again, this significantly changes your answer if you're not using the degree unit. So in this case, we are rounding to the nearest tenth. Okay, so 0, but the next value is 1, so we keep it as 0. So really, our measure is 3 units. All right, so let's place it here. Okay, so it's an area, so we're going to say round it. It is going to be 3 meters squared, or squared meters. That's the area of this given triangle. Okay, so that's the given area of this given triangle. All right, so let's go and have you practice on another problem right here. So it does help that you set up your triangle and label them accordingly. It doesn't matter where you place the letters as long as you know what you need to use. All right, so I personally labeled A, B, and C like so. And what I did was this. I made sure that the A angle had the measure, which means going back, all right, we will be using the top formula. All right, so let's try this out. So let me give you a second to pause the video right now, and then whenever you're ready, you can play it. All right, so let me show you what we did here. So to find the area, we are using the first equation that we mentioned. So let's go ahead and take a look at that. We're going to enter the information we have, the side lengths 8 and 12, and then the sine value for 86 degrees. And you enter this in your calculator, making sure you're in the degree mode. And when you do, you need to round it to the nearest tenth. Okay, make sure you're rounding to the nearest tenth. All right, and once you do that, you're supposed to get something close to this. So 4788, because we're rounding, it's actually 47.9 square feet. And that's the area of this given triangle. So class, I highly encourage you to type this entire equation into your calculator. Do not do it part by part, especially if you're rounding. As you round through those steps, it significantly changes your answer. So I do not encourage that. I want you to type this in as you're seeing it right now into your calculators. All right? All right, let's go forward. So we're actually jumping into the law of sines. According to your law of sines, right, in a given triangle ABC, as you're seeing right now, it states that there are ratios that you can set up. And once you have this ratio, it's actually going to be a proportion. All these sides are related to each other as well as their angles, especially with the law of sines. The law of sines also allows you to solve a triangle as long as you know either of the following. Okay, this is you going back to geometry, just recalling a little bit. We are now going to discuss the two angle measures and any side length. So, or the angle side form, okay, or the angle side angle, whichever that may be. Or two side lengths and the measure of an angle that's not in between. So this angle that's given should not be in between the two sides, all right? Okay, I'm going to share the code with you right now. Code number 1 is happy. Happy. I'm so happy. All right, so let's actually apply the law of sines right now. All right, so I have this given example. We're instructed to find all the measures that are unknown. So the instruction goes solve for all the measures, or solve the triangle. What that essentially means is we're going to find all the unknown parts. So in a triangle, you're supposed to have 3 angle measures and 3 side lengths. Okay, so that's what we're going to check right now. Okay, so in this triangle, we only have 2 angle measures, which means we need to look for, let's make a list, right? We're going to look for the measure of angle T. And then we have 3 sides, but right now we only have 1 side length. So that means we're looking for the measure of T, this side right here, and the other side, which is R. So there are 3 things we need to look for. And in order to find those, we can use the law of sines right here. So let's establish this. Obviously, you're not seeing A, B, and C. What you can do is replace it. So maybe you can change the variables according to what works best for you, or you can replace it here just to give you some guide. I will label it as A, B, and C like so. All right, it's up to you. You can do it a different way. All right, so that will allow me to set up my equation. All right, so let's look at this. So this for me will be sine S over side S, and then sine R over the R length, and then sine of C over side C. All right, so let's actually replace these variables with the given measurements. I will enter 40 degrees here over the S side, which is 20. I know this. And then sine R, which will be 49 degrees, over the R length, which is unknown. All right, so sine C. All right, so here's the thing. Notice how we're missing sine C, or should I say T? Sorry about that. This should be T, side T. All right, we're missing side T and angle T. We are going to locate them. But for that to happen, notice that immediately you need to find the measure of angle T. And how would you do that, right? If you remember, in any given triangle, the total sum of the angles should be 180. So that would be step 1 for us. Find the measure of angle T. And like you said, because the total sum should be 180, we take away the 2 given measures, and in this way we're going to be able to identify the measure of angle T. And we're saying that angle T is actually 91 degrees. Okay, go back to your checklist. That was one of the information we needed to find. Okay, so we can now plug that in here. This is actually 91 degrees. Awesome. All right, so we found one of the missing parts. Now we need to find the 2 side lengths. And how are you going to do that? All right, so this is where your cross multiplication will come into play. All right, so this is what I need. You need to decide, you want to find side t or side r first. Okay, for uniformity, we're going to find sine t or side t, since that's the next on our list. Okay, so let's label it. Solve for t. We're solving for side t. All right, in order for that to happen, you obviously need to use the given information where you can find t, the fraction for sine of 91 degrees over t, and we need to set that equal to any other of the given ratios that have a complete set of information. Why? Because we're looking for t, and we can't miss any other variables. So I can't set it equal to the one with an r value because we still don't know what r is. All right? That means we're setting it equal to sine of 40 degrees over 20. Okay, so we've set up our equation. The only missing variable in this given is t, and that's what we're trying to solve. Because you have a fraction equal to another fraction, you are allowed to use your cross multiplication. All right, so how does that actually work? Let's list it down here. This will become t multiplied by sine 40 degrees. Yep, all right, equal to 20 multiplied by sine 91 degrees. Okay, but see, this doesn't really tell us yet what the measure of t is, because now we need to actually isolate the variable. And for that to happen, ask yourself, what am I solving for? We are currently solving for t, and t is right here. How can you keep t by itself? All right, you have to eliminate sine 40 degrees. So let's divide by sine 40 degrees. We are dividing the other side as well, keeping our equation balanced. So to find the measure t, you will have to enter this into your calculator as a fraction, and it needs to look like this exactly over sine 40 degrees. Okay, now I understand some of you don't have a calculator that allows you to type in a fraction, so let me write it out for you. For those of you who don't have the capacity to type in a fraction in your calculator, here's what you can use. I will encourage you to use a parentheses. Okay, writing down our numerator first. Okay, yours might have more parentheses, and that's okay. This is the numerator. Notice how I enclosed it in a parentheses. This tells the calculator that's the numerator. And then you're going to do your division symbol. And then you're going to open another parentheses and enter your 40 degree or sine 40 degree function below. All right, so let's actually look at a calculator to help us find the information. All right, so again, whichever you have right now, you will enter that information. I'm going to create a fraction, so alpha, and then y equals, I'm going to select the first one. In our numerator, we said that we are going to enter 20 sine, okay, I'm not checking my mode since I know we set it earlier to degree. All right, so 91, this is our numerator. I'm going to go to my denominator and enter sine of 40 degrees. All right, click enter. What we have right now is a measurement of 31.109. We're going to round to the nearest tenth. So we're saying that the angle actually measures 31 point, or not the angle, sorry, the side length measures 31.1. So let's go back and enter the information here. So side t measures 31.1. Okay, so notice how I didn't do any rounding in between. I entered the entire equation, whatever it looks like in my steps, so I don't need to worry about losing points or specific values that will significantly change my final answer. All right, so going back, we found side t. All right, so we're now down to our last side length. Okay, you might be thinking right now, oh, okay, you know what? Let me use the Pythagorean theorem. No, you can't. Why? Because you don't have a right triangle. All right, so this is why you have to use the law of sines and continue to apply it since you don't have a right triangle. All right, so let's go ahead and find r. So let's label it once again right here, solve for r. In order to solve for r, again, we take any two of the given setup fractions that we have here. So you know you're going to have to use sine 49 degrees over r, since you need to find r. Okay, so at this time, because you found t, you can either choose sine 40 degrees over 20 or sine 91 degrees over t. You have that option now, okay? So in this case, I'll continue to use the sine 40 degrees over 20, okay? That's my preference. Again, you can choose the other one. The result should be the same. All right, and now that we have your fraction, you have a ratio and your proportion set up, you're going to cross multiply. So I'll go 20 sine 49 degrees is actually equal to r multiplied by sine 40. All right, so I enjoy using parentheses just so I can really see what I'm multiplying together. Okay, see how that makes so much sense? Oh, that's where the 20 went. I'm multiplying it by sine 49. All right, so we're solving for r. Our objective is to isolate the variable. We can do that by dividing by sine 40 degrees. All right, let's apply that. And once again, now you're saying that r can actually be found by using the given setup. 20 multiplied by sine 49 in our numerator over sine 40 degrees. All right, let's actually go ahead and enter that into our calculator for the benefit of everyone. I will be entering this now using a set of parentheses, okay, just so we can see both methods. All right, I'm going to enter the numerator starting with the parentheses, 20 sine 49. Okay. Okay, notice how I'm closing it twice. The first closed parentheses, or closed one, is for just the initial 49. A second one is for me to close and say that that's my numerator, okay? All right, let's divide it, opening another parentheses for sine of 40 degrees. All right, we're gonna close it twice as well, okay? All right, we're gonna hit enter, and we should get a 23.48. Again, rounding to the nearest tenth. So this will be 23.5. All right, let's go back to our screen here. And we're going to say that that's actually 23.5. All right, go back to your checklist. You found the measure of angle T. We found side T. And now we've also found side R. And this is what it means to solve for the triangle, or to solve for all the unknown parts. Okay. All right, so on the next screen, you're going to have an opportunity to try this out. Okay, so I have a given measure here with a given triangle DEF with the given angle measures and side length, 9, with the unknowns of E and F. So again, you want to start out by labeling whatever information you need to find. We've set it up over here. We need to find the measure of angle D and the two side lengths E and F. Okay, so you can pause the video at this time and give yourself some time to try it out. All right, so I think we can continue now. All right, so we set up our equation or our information up here. Okay, identifying what we need to find. So in order to find the measure of angle D, you want to start by identifying this measure, taking away 141 and 23 from 180. All right, so let's see what you have right now. Okay, so I'm going to show you half my screen, like so. Okay. All right, we found that measure of angle D is actually 16 degrees. Okay, so we're going to put a check mark on that one, signifying that we found it. All right, done. Next, we can set up your sine, law of sines, like so. Sine 16 over 9, sine 141 over E, and then sine 23 over F. Okay, so notice how we've incorporated the 16-degree measure now. All right, from here, you decide whether you want to solve for E or F first. In this case, I've decided to solve for E first. All right, in order to solve for E, I set it up the ratio for E. I've set it equal to sine 16 over 9. Okay, because it's a complete information and I only should have one variable missing at a time. That's why I can't set it up with F. All right, now that I have done that, let's take a look. All right, so scrolling over here, I'm going to show you the steps. All right, we've cross-multiplied the given, like so, allowing us to set it up in this manner, where obviously we're solving for E, so we need to eliminate sine 16 degrees. Thus, we divided it by that. And so going forward, you have this expression to enter into our calculators to help us evaluate. All right, when you do, you result with something like 20.54, but because we're rounding to the nearest tenth, it should be 20.5. All right, and now we've actually found your side E. So let's put a check mark. We found side E, and now we're down to the last side length. And at this point, you continue to use your law of sines. All right, so we're going to solve for f, labeling it once again like so. All right, let's look at the next step. We've set it up. Again, at this point, you have the option to use sine 16 degrees over 9, like I did, or if you prefer to use the second ratio, since you have E, you can do so. Okay, whichever you choose will work just fine. We're going to cross multiply. Okay, that results in f sine 16 degrees equal to 9 sine 23 degrees. However, because you're solving for f, okay, think about this. What are you dividing the equation by? Okay, you're trying to isolate f. All right, so yes, you do divide by sine 16 degrees. And in doing so, we're going to use the given function, or the given expression, sorry, the given expression like so. We're going to enter into our calculators, and as a result, we're going to get 12.75, again, rounding to the nearest tenth, because that's the instruction, which gives us 12.8. So at this time, you found the angle measurement, one side length, and now the last side length. And now we're done with this question. All right, so hopefully you're seeing the significance of actually using your law of sines. It really helps to set it up and carefully apply your steps, cross multiplying and eliminating. All right, let's go forward now. So at this point in the lesson, you've had the opportunity to try it out. Okay, so you've had the chance to evaluate functions using sine. All right, so you found a side length, you found angle measures. All right, so right now I have two more examples for you to take a look at. Okay, you can pause the video right now and then play it whenever you're ready. All right, so let's take a look at 2a first. Problem 2a right here with the given two angle measures and a side length. Okay, I'm going to show you the answers right now. I'm going to walk you through it briefly. Okay, all right, so we start by finding the measure of angle k like so. Now that we've found angle k, we're going to create our law of sines with the given ratios and set them up equal to each other. We've incorporated the 31-degree measure that we found. Now you have the option to start looking for h or k first. That's a preference that you need to work on. In this case, I've chosen to start by looking for side h. And when I did, I ended up with a given proportion. Applying my cross multiplication method, I end up with h being an expression for the following. I entered this into my calculator and I've resulted in an 8.4 measurement. All right, so right now we found the last angle measure and one side length, which means we have one more side length to look for, side k. To solve for k, all right, we've listed it down as well. At this point, you have the option to choose and use the same expression I did, sine 107 over 12, or if you prefer to use sine 42 degrees over h, since we found h, that will work just as well. And once we've done that, we found k can be found by using the expression 12 multiplied by sine 31 degrees all over sine of 107 degrees. After evaluating into our calculator and rounding to the nearest tenth, we found that side k is actually 6.5 units. All right, so this was for 2a. Let's go ahead and take a look at 2b. In 2b, you have two angle measures once again with a side length given 1.5. All right, so let's start by looking again for the initial one. I'm going to show you the steps now. Okay, solve for the angle measure n. In this case, we found it's 18 degrees. And now that you've found the angle measure, you're going to incorporate it into your law of sine setup like so. All right, so we have the given measures. In this case, we're starting to solve for p first, side p. And I've chosen to use our first fraction with a p and set it up equal to sine 18 degrees over 1.5. After applying cross multiplication, I was able to simplify it so that P is actually 1.5 being multiplied by sine of 56 degrees over sine of 18 degrees. And once I've evaluated, I found it to be 4 units. Okay, so at this time, for example, 2B, you found an angle measure and you found one of the side lengths that was missing. And now we're down to our last side length, solving for side M. In order to do that, you have the option to use the same setup I did, where I use sine 18 degrees of 18 degrees over 1.5, or if you prefer to use sine 56 degrees over P, which is 4, because we found it, that's totally up to you. But I found that side M is actually 4.7 units long. All right, so hopefully you're checking your answers, rechecking, and then reviewing. All right, okay, so at this time, with this lesson, you've evaluated and you've used your law of sines to find angle measurements and side lengths. I'm going to go forward. Use the law of sines to solve a triangle like we did, okay, where we knew the two side lengths and an angle measure. Okay, so there could be 0, meaning no triangles, 1 or 2 triangles that are possibly going to be created based on those information. And when you talk about that, that's when what you call the ambiguous case comes into play. When you say that, there are 2 possible setups for this. This is the information you're going to look at. All right, so you will be given 2 side lengths and an angle measure. Now, let's take a look at that angle measure first. If that angle measure, all right, is acute, anything less than 90 degrees, you're going to look at the information on the left side of this given table. All right, where you start by identifying h, which is the altitude or the upright height, okay, producing a right angle, as you can see. All right, you're going to identify h first and tell whether that's greater than h, equal to it, or between the other side lengths, or is less than the other side lengths, or maybe it's a totally different case. Okay, so you say this if A, the angle measure given, is acute. On the other hand, if the angle measure is right or obtuse, larger, right, we're going to refer to the following information. It's either that the side length A is less than or equal to B, meaning no other triangles can be produced. Okay, no triangle can be produced at all. Or that the side length A is greater than B, meaning there's only one possible triangle we can create. All right, and there are 3 steps to really guide you through this. So always start step 1. Okay, use the values of A, B, and the measure of angle A to determine the number of possible triangles. So like we said, start by identifying, is the angle A acute or obtuse? If so, refer to the given cases listed on our table. So it is really important that you have a copy of this table in your notebook. All right, step 2. Now that you've identified if there is one triangle, that can be produced, then you can go ahead and solve for the unknowns. All right, step 3. Well, if there are 2 possible triangles, then you must find those 2 triangles with their given respective missing angle and side lengths. All right, so let's look at an example right now and actually give some more meaning to this. Okay, so right now it's a lot of table and information, but shortly you're going to see how that's very useful. All right, let's look at this one. So Maggie is designing a mosaic by using triangle tiles of different shapes. All right, so it's not the traditional single-sized shape or single regular triangle. All right, so we're going to determine the number of triangles that Maggie can form, all right, using the given measurements. You have the A measurement of 11, and then the B measurement of 17, and of course angle A of 30 degrees. And then we're going to solve the triangle, meaning we're going to find all the missing parts, and we're going to round those measurements to the nearest tenth. The second code word is watch. Okay, it's been a while since I've worn my watch because I've been looking at my phone or my computer for the time. Second code word is watch. All right, let's get you started. So let's make sure that we follow the steps. Step 1 was to make sure that we're identifying whether the given angle measure is acute or obtuse. In this case, we say that the measure of angle A is going to be acute because it's 30 degrees. All right, that means we're only looking at this left side of the table. So you can go ahead and cross out the right side. You don't need to look at that right now because we've narrowed down our option here. All right, ambiguous case because there are possibly no triangles or one or two triangles that can be produced based on the given. All right, so moving on, that was step 1. Now we need to identify if the A value given and the B value given can be confirmed by looking at this. All right, so we're going to jump right into the one triangle option. Is our A value greater than the B value? No, it's not. So you can cross this out. All right, that narrows down our options to these 3. All right, so let's observe this. In the given measures, or the given cases, you will need to find a measurement called H. Again, H is the upright height. It's the actual height of your triangle. So let's set up a visual for the given. Okay, so let's draw a triangle. Okay, again, not drawn to scale, not really exactly what it should look like, but give it an estimate just so you have a visual. Let's label them as A, B, and C, where we said that the angle measure is 30 degrees for A. The side length A across it is 11 units. The side length B is 17 units. All right, so now we've set it up. Where would the upright height be found? Okay, so let me show you where that's found. Okay, you can find it between when it's a height from the vertex C all the way down between A and B. This is the upright height H. Okay, the altitude, if you want to call it that. All right, so now that we have this information, our question remains, how do you find H? So ask yourself, all right, you've just produced a right triangle here. There's actually 2 triangles that you've generated. Now, to find H, all you know is this. You have side lengths available in an angle measure. I obviously cannot use the right-hand side of the right triangle that we've generated because you only have one information, the side length, which means you are only using the left side. All right, so let's set it up. What do you know? You have an angle measure. That's going to be theta. You have an opposite side and a hypotenuse, which means you're going to be using the function sine. So we're going to say we're using sine 30 degrees, which is opposite H over the adjacent side, or the hypotenuse rather, which is 17. All right, so we're solving for H, and we can do that by cross multiplying. So right now I have 17 multiplied by sine 30 degrees will give us the height. And again, you enter this into your calculator and evaluate it, and we end up with finding that H is actually going to be 6.5. All right, 6.5, yes? All right, so let's go back here. A value is 11. Is the A value less than H? No, it's not. Well, is A equal to H? No, it's not either, which means that the H value we found, 6.5, is less than A, which is 11, which is also less than 17, our B value, which means we are actually going to create 2 triangles. All right, so we've answered one of the first questions. Determine the number of triangles that Maggie can form, and we're saying that it can create 2 different triangles. All right, so at this point, you're actually going to create those 2 triangles and find the angle measures as well as the side lengths that are needed. All right, so let's start. I'm going to start by listing down the first triangle. So let's call this triangle number 1. Okay, since we're creating 2. All right, triangle number 1. All right, for triangle number 1, we're going to set it up. I'm going to copy the image that we have here. All right, what I mean is this. Notice how the red lines or red rays are swinging. So there are 2 images you're creating. We've actually created one of them already. Notice how this triangle we've generated looks like where the red line is going outside the height, or the h. You see it? Okay, so we're going to refer to that same image. Nothing has changed. Right, we're keeping this image like so with a 30-degree measure here. All right, at this point, you're going to start using your law of sines to help you identify a few things. Okay, all right, so let's set up the equation. So sine of A, which is 30 degrees, over 11. Sine of B, unknown, we don't know yet. And all we know is that the side across it is 17 units. And then you have sine C with an unknown side length across it as well. All right, so let's go ahead and use any of these two to solve one of them. For now, we can start by identifying the angle measure for B. All right, so let's start by identifying angle B. Okay, so it doesn't matter if you start with this or if you start looking for side C or angle C, totally fine. All right, in this case, I'm going to start looking for a measurement of angle B. In order to do that, I need to set up my equation. So I'm going to use the first two fractions like so, okay, because I'm looking for angle B anyway. All right, and then we're going to apply your cross multiplication steps. Let's write it up here. So I'm going to go and break down 17 multiplied by sine of 30 degrees is equal to 11 multiplied by sine B. All right, so very nice. We've set up our equation. We've cross multiplied. Now we ask ourselves, what are we solving for again? We're solving for the measure of angle B. In order to do that, we need to isolate sine B by dividing by 11. All right, so sine B, or sine of angle B, is going to be 17 multiplied by sine of 30 degrees over 11. All right, but notice how we're not really looking for a measurement of angle B yet. Okay, so this is where your inverse function comes into play. Because you're looking for an angle measure, you need to use the inverse function. Okay, this is what I mean. To find the measure of angle B, you need to use the inverse function. So now we say the inverse of the given measures will give us the actual angle measure for B. So we're going to replace, see how we use the inverse function that we did in the previous lesson? That's why it was so significant and important for us to identify these. And we are now going to evaluate by entering this into our calculator. Let's go into the calculator right now. All right, so let's enter that information. All right, we're going to use and create a fraction to help us plug in the information we need. All right, so remember how we're using, I'm sorry, I should have started with this. Remember how we were using inverse? Okay, you need to use the inverse function. There are the blue functions here. Do you see it on your calculator? Which means you need to use the second function and make sure that it's in inverse format. All right, now that we have that, we can enter the information we need. You're going to enter, we said 17 multiplied by sine 30 degrees. Again, I'm not changing my my mode since I know I've set it up to be in degrees because we did that earlier. And we're going to divide this by, we said 11. All right. So notice how everything is nicely placed into the parentheses. The denominator is just 11. All right, we're going to hit enter. And this right here is going to be the angle measure for B. Okay, again, we're rounding to the nearest tenth. So this will give us 50.6. All right, let's go back to the whiteboard. All right, so we said that that was going to be 50.6 degrees. All right, very nice. Okay, so you found angle B. All right. Okay, so we forgot to create a list, so let's write them down here. We needed to find angle B. We've done that. And now we need to find side C. Side C. We don't know side C yet, so let's find it. We also need the measure of angle C. Yep, all right, 3 things we need since we only have half of the information. All right, so because you found the second angle measure, we can easily identify the measure for angle C. So let's write it down here. So the measure of angle C can be found by subtracting the other two angle measures that we have. All right, 50.6, and then the other one was a 30-degree measure. And once you do that, the measure for angle C should be exactly 99.4 degrees. All right, there we go. All right, so we've identified the two angle measures, which means we have one last information to look for, side C. And how do you do that? All right, so go back to the setup that you created for the law of sines, applying it. Okay, we're looking for side C. That means you need to use sine of C, which is we found to be 99.4, and set it up equal to whichever of the other two fractions you have. At this point, it doesn't really matter which one because we will result in the same answer. All right, so let me set it up. In this case, I'm choosing to set it up with the sine of 30 degrees over 11, okay, just to keep things constant. I will apply my cross multiplication method. All right, right now we're solving for side C right here. All right, cross multiplying, you have 11 multiplied by sine of 99.4 equal to C multiplied by sine 30 degrees. And then we ask ourselves, what are we solving for? We're solving for C. Because of that, I need to isolate C and divide this by 30 degrees, sine 30 degrees, like so. So to solve for C, we have 11 multiplied by sine 99.4 over the sine value of 30 degrees. All right, again, you enter this and evaluate this into your calculator. Okay, and no, you do not need to use the inverse because you're not looking for an angle measure. You're just looking for a side length. And once you do, we end up with a 21.7 unit measure. All right, so we found the two angle measures we're missing, including the side length C. All right, so this is one application of your triangles, your sine, the law of sine, and how there could be ambiguous cases where you can either have no triangle available or to possibly use, or just one or two. All right, however, we said that we needed two triangles. What we did was to create just one of them. Now, on the next slide, we're going to create another triangle, okay, the second one, okay? All right, so let's create the new triangle. Insert a page after current. All right, we are now ready to create our second triangle. In order to create the second triangle, we're using the same information, where A still measures 11 units and B still measures 17 units, the same information. But what's going to be different this time, right? We forgot to write this down. Angle A remains to be 30 degrees. What will change are the other three measurements that you found. So in triangle number 1, those information only referred to the given. So for this second triangle, triangle number 2, we need to create a separate, different setup. Here's what that means. Okay, so in this situation, okay, we're going to start by identifying first what we need. We obviously need angle B, measure of angle C, and we also need side C. So two angle measures and one side length. All right, so because in the previous example, in the previous triangle, let me go back. In the previous triangle, we've already identified angle B. So angle B, if you go back here, we found angle B to be 50.6 degrees. What's really cool about this is for the second triangle, you don't need to go through the same method because you will eventually end up with a 50.6 degree measure. Instead, here's what we're going to do. Angle B for the second triangle, okay, will be an obtuse measurement. Will become obtuse. Okay, what does that mean? It should be a measure greater than 90 degrees. And what would that look like? How do we find it? Here's how. Because it needs to be obtuse and it needs to be within the measures of a triangle, we are going to take it away from 180 degrees. Okay, 180 degrees because that's the total sum of all the angles in the triangle. So we're going to take away the measurement we found, which was 50.6, And this will produce an obtuse measurement of 129.4 degrees. This right here is the measure for angle B. Okay, so we found one of the other angle measures. Okay, it happens to be this way because now we're looking at a totally different triangle. And what would the illustration look like? All right, let me go back once again. Notice how this triangle we used for triangle number 1 came about because of the red line that was protruding, the one that extends outside of the altitude or the right height, upright height. All right, so notice that, right? Okay, so we're going to now do the other measurement, or the other red line right here, where it's going inside. See how that's going inwards? All right, let's draw it out right here, just so we have a visual, especially for those of us who are very visual. So normally your triangle looked like this, okay, right? But now because we're using a second triangle, if these were the upright, okay, I'm going to attempt and draw, this is the upright height here with a 90-degree triangle. If you remember, the red was supposed to go inward from that position. Okay, let me go back, show you one more time. We're trying to illustrate this innermost red side. See how it's going inwards? That's what we're trying to illustrate. All right, so it looks something like this. All right, let me get rid of the H out here. Okay, so that now it looks more like the triangle we want it to be. There we go, right there. Okay, so this is the triangle that we're going to use and recreate. Let's label the information we have. This will remain to be A, B, and C. Right, where A measures 30 degrees, side B is 17, side A here is 11. All right, and now we've found the measure for angle B. We can locate and identify the measure for angle C. Again, from 180 degrees, it's the triangle, that's the total measure. Let's take away the 50 degrees, or sorry, not the 50 degrees, the 129.4 measurement. And now we can also take away the 30-degree measurement from angle A, all right, allowing us to solve for angle C, which is going to be 20.6 degrees. All right, we found the measure for angle B and angle C. Now we're going to attempt and look for side C. In order for that to happen, you need to create your setup with the law of sines, using the law of sines. So solve for C. All right, so you know you're going to need angle C, so we're going to list that down. Angle C is 20.6, so sine of 20.6 degrees over side C, unknown. And you can choose to use sine A or sine B. It really depends on you, but in this case, I would prefer and use sine of 30 degrees, so using sine A over the A side, which is 11. Okay, so from here, we're going to cross multiply like we did previously, allowing me to create the setup right here. And again, we ask ourselves, what are you solving for? You're solving for C. You need the C variable by itself. That means you need to eliminate sine of 30 degrees like so. Eliminate. You can divide this. So that now you're really just solving for C, which is 11 multiplied by sine 20.6 degrees over sine of 30 degrees. You enter this into your calculator, making sure you plug in the correct values and that your mode is in degree. And then you evaluate it, and we find that side C will measure 7.7 units. All right, so we found all 3 possible measurements. Okay, so this is really the measure of our second triangle. So notice how it's very different. It's very unique from the first one that we've created. So yes, the values will change because it's a completely different triangle. Okay, because we've established that from the beginning, when we confirmed the significance of the measure of angle A, 30 degrees, and the height, the upright height, it informed us that there were supposed to be 2 possible triangles created out of these measurements. All right, so that's how we came up with the 2 triangle measures. All right, so on the next page right now, you're going to have another opportunity. So Maggie is trying to play around with a few more measurements. She's now playing around with a measure of 10 units for side A, 6 units for side B, and the measure for an angle, angle A, which is 105 degrees. All right, we're going to solve the triangles and round it to the nearest tenth like we did previously. All right, so here's my other code word number 3. Chocolate. Wouldn't it be nice to have some chocolate this time? Code word number 3 is chocolate. All right, so let's continue. All right, so with this example, again, you can pause the video right now and give yourself some time to try this out. And whenever you're ready, you can continue. Okay, so we start asking ourselves again, okay, what am I doing here? What am I going to identify? I first need to know, I need to determine how many triangles Maggie can form, can create using the following information. And you always start by following the 3 steps. Step 1 is to identify whether you have an acute or obtuse measure for angle A. In this case, angle A is 105 degrees, meaning it's obtuse. So we don't need the information on the left side of your table. Okay, so notice how this is really useful. All right, we're referring to the right side. Because the measure is obtuse, we are going to compare the measures of side A and side B. A is 10 units, B is 6 units. All right, so is 10 units less than 6 units? Nope, but 10 units is definitely greater than 6 units, which means the given information can produce a single triangle, and it will look something like this. All right, so let's set it up. I'm going to set up a triangle that looks something like that. All right, not as good as it should be, but good enough. All right, 105 degrees for angle A. Angle B right here, angle C right here. And we said side A is 10 units, side B is 6, and side C is an unknown. All right, so now our objective is to find all these other measurements. First, okay, we said there's only one triangle, so let's make sure we're very clear on that. We don't need to solve 2 because we just need 1. We can only create a single triangle. All right, so let's set up your equation using the law of sine. So I have sine of A, 105 degrees over side length, sine of B over side length, sine of C over its own side length, like so. All right, so from here, from this point, you can decide to start by looking for the angle measures or the side length. All right, so in this case, I'm going to start and identify the measure for angle B. To identify and measure or find the measure for angle B, we're going to use sine of 105 degrees over 10 and use it to cross-multiply with the second fraction. In doing so, we're solving for angle B. Okay. All right, so remember how we solve for the measure of an angle? You must use the inverse function. Okay. In order to get there, we're trying to isolate, okay, the angle measured first. So we're dividing by 10, all right, like so, because now you're left with sine B and rewriting the equation so everything is in standard form. So 6 multiplied by sine of 105 degrees over 10. But because we're looking for an angle measure, you need to use the inverse function. And if you remember, it will look like this. I'm going to write it on the left side. The measure of angle B can be found by using the inverse of the sine function for 6 multiplied by sine of 105 over 10. And we will enter this into our calculator and evaluate. All right, so let's go back to your calculator and look at these steps right here. All right, so we're going to create, so we've created a fraction previously. For the benefit of the others, we're going to now use parentheses. I'm going to do the inverse sign, first thing we should do. And like we said, we are going to now enter the numerator information. So that we can enter the numerator, we need to open a parentheses, like we did. We're going to type in what we need. So 6 is being multiplied by sine of 105, like so. This is the numerator. Okay, I'm going to close it. I closed it one more time because that's my numerator right there. Okay, Now I'm going to divide it by the denominator. So I'm opening another parentheses and entering 10. Okay, I'm closing the denominator. Now I'm closing the entire equation. Okay, so it will show an error if you miss one parenthesis. So it really helps to be very careful. All right, I'm going to go ahead and hit enter. Oops, see what I mean? All right, so let's see what the issue was. Maybe I missed one. Oh, okay. So I entered one too many parentheses at the end. All right, I've removed it. Let's hit enter once again. All right, so in this case, I'm seeing that it's 35.419, or rounding to the nearest tenth is 35.4. All right, let's go back to the whiteboard and enter that information. All right, so we found the measure of angle B is actually 35.4 degrees. All right, wonderful. We've found angle B. All right, now we need to find angle C. So solve for angle C. We can do this by subtracting the two other angles that we know of, 35.4 and 105 degrees. And so we say that angle C is actually going to be 39.6 degrees. All right, we found your two angle measures, which means we have one side length to look for, side C. To find side C, we go back to the setup we created and use any two fractions to locate that. All right, so we're going to solve for C. All right, at this point, you can choose any two. I will choose sine of 105 degrees over 10 and set it up equal to sine of 39.6 because I need side C, right? Okay, like so. And then we're going to cross multiply C multiplied by sine of 105 and 10 multiplied by sine of 39.6. All right, again, ask yourself, what are you solving for? You're solving for side length C, so you need C alone. So divide this by 105, so as the other side, so it's balanced. So we can actually find side C by evaluating the following. All right, so make sure you enter this carefully into your calculator. Make sure to double check your values in your decimals. Rounding to the nearest tenth, we say that side C is going to be 6.6 units. All right, so hopefully we've covered the entire section 5, which is the law of sines. And it has so many uses, and I'm really hoping that you've taken the opportunity to pause the video and practice, and then continue by checking your answers. All right? I'll see you really soon. Please make sure to list down any questions you have, and remember the 3 code words, and you know what to do. See you again. Bye for now.